Hello students, welcome to Modern Group of Education. So this is the second lesson of Electrostatics 01 and this video will be based on the examples of Coulomb's law and superposition principle. So if you didn't watch the last video, then please go and watch the last video and then come here. Okay. So now starting in the video, that the Coulomb's law and superposition principle. Okay. There are three questions. The first one is two point charges plus one q1 is equal to plus 2 10 to the minus 6 coulomb and q2 is this are separated by a distance x 10 centimeter. Find the magnitude and nature of the force between the two charges. Okay, now you are thinking that sir is actually doing very basic questions and wasting our time. No, this is not. This is actually a basic question, but there is some error prone area in this question and you have to identify this. Okay, so I am starting this question. So Coulomb's force is F is equal to K Q1 Q2 by R square. Okay, the value of K is if we apply the value of 1 by 4 pi epsilon naught, that means 1 by 4 pi into 8.85 10 to the power minus 12, then the value of K will be 9 into 10 to the power 9. So if you apply the value of K, that is 9 into 10 to the power 9 into Q, that is 20 into 10 to the power minus 6 into 3 into 10 to the power minus 6 divided by the distance 10 centimeter, that means 10 into 10 to the power minus 2 whole square, you will get the answer. But so where is the error prone area? The error prone area is this. Some students did what? Some students do, they put the sign of the charges. They put just like this, 9 to the power 9 into plus 2 10 to the power 6 into minus 3 10 to the power minus 6. This is wrong, because in Coulomb's law we are applying this as the scalar form. So you have to apply the value magnitude of charge only. We will find the force separately. Okay, so you have to put the value of charges without their sign. Okay, so this equals to 9 10 to the power 9 2 10 to the power minus 6 10 to the power minus 6. This you have to calculate the answer. 9 into 18 18 into 3 54 54 into 10 to the power 9 9 10 to the power minus 6 minus 12. So it will be 10 to the power minus 3, and here in denominator it is 10 to the power minus 1 into 2, that means 10 to the power minus 2. This is called 10 to the power 54 into 10 to the power minus 1, that is 0.54, sorry 5.4 Newton. 5.4 Newton. So this is the answer, 5.4 Newton. So I get the I find the magnitude, and the nature of the charge is attractive because both the charges are opposite in nature. So it is, the answer is attractive. This is the final answer. Okay. Now going to the second question. 2 point charges Q1 and Q2 are placed minus 1 1 3 1 minus 2 respect to some coordinate axis. The coordinates are in meter. Find the component of the forces along 3 coordinate axes. Also find the net magnitude of the force. So here Q1 and Q2 is given and R is not given, but the coordinates are given. So you have to find the R vector first. So the R vector is minus 1 minus 3 I cap plus 1 minus 1 j cap plus 1 minus of minus 2, that means plus 2 k cap. These things are taught in class 11. Okay, this is the x value. You have to find minus the x values and I cap, y values and j cap, and z values with k cap. So this is the minus 4 I cap, and 1 minus 1 is 0, and 1 plus 2 is 3 k cap. So R vector is this. This is the R vector, and the R magnitude of this R vector is root over of 4 square plus 3 square, which is 5. Okay, so now put the value of F equal to K Q1 Q2 by R square. Q1 is 20 minus 6 and Q2 is 25 minus 6 and divided by 5 square. So it is 90 to 180, 180 into 25 minus 12 divided by 25, which is 25 get cancel out, and 180 minus 12 into 9, that is 180, sorry, here 180 minus 9 minus 12 in plus 9, that means minus 3. So answer is 0.18 Newton. So this is the magnitude of force. Okay, got it? Next question. Two equal charges are placed at a separation d, where and of what magnitude a third charge be placed so that all the three charges are in equilibrium. This is a very important question. This is a type question. Some type of question we have to practice. So this is one type of question, that two charges are separated. They are equal charges. They state that these are equal charges, are separated by a distance d. Okay. So where and what magnitude of third charge we place so that all the three charges are in equilibrium. So equilibrium means the net force acting on a body or a charged particle is 0. Okay. So we have to place a third charge, but the question is, what is the third charge? Is it positive or negative? Now here the concept came of test charge. Test charge. What is test charge? Test charge is a charge by the application of which we can find the electric field, okay, of any place. So test charge is the charge by which we can find electric field. So the value of test charge is always positive. It is a very small, the properties are very small. Properties of test charge is it is a very small and positive charge. Who told me this? This is a very small and positive charge. No one told me. It is an assumption. You have to take some assumption to find the electric field. So this is the assumption. You have the test charge. The test charge is a very small and positive charge. And there is a third property which is very important of test charge is there is no electric field. There is no electric field around a test charge. There is no electric field around a test charge. There is no electric field around a test charge. That means in the around the electric field there is no test charge. Around the test charge there is no electric field. But you know that every charge has their electric field. But there is no electric field around a test charge. Why? Because we have to find the electric field of others by a test charge. So the test charge shouldn't have the electric field. Okay. Otherwise the electric field got disturbed and we will find the wrong answer. So the test charge has no electric field. Okay. So there is no electric field around the test charge. Okay. So now there are three places to place a charge, that is here, one is here, one is here, and one is here. I am erasing all these things because I am erasing all these things to clear your space, clear the space. Okay. See, there is some possibility of the placing of charges here, here, and here. Now place a positive small charge. See that this plus charge will repel this charge towards this, and this plus charge will repel this charge towards this. So is it possible here that equilibrium state will be reached? Equilibrium means the net force acting on the particle is 0, but these forces are acting towards same direction. So there is no possibility of equilibrium. Okay. Now here the plus q charge is towards this, repel the plus q charge, this plus q charge repel this charge towards this, and this plus q charge repel this charge towards this. So here is some possibility of equilibrium. Okay, because these forces can get cancelled out. Okay, but here this plus q charge repels this in this direction, and this plus q charge will repel this charge in this direction. So here is also there is no possibility of equilibrium. So I am erasing all the other options and only keep this option to make you understood clear. Okay. Now this is the distance d between the two charges, and take the distance x. This is the distance x. So I am applying equilibrium condition in this charge, but in this question it is written clearly that all the three charges are in equilibrium. That means you can apply force of any one of them, all the three charges will remain in equilibrium, but I am taking the force on this charge by the other charges. So this charge, the force of this charge by this charge is kq into q by x square. Okay, and the force on this charge by this charge is kq into q. This distance is what? D minus x. So d minus x square. So q gets cancelled out, and one there is both side, in this both side there is square form, so you can write this d minus x. Okay, so d minus x is equal to x, and it is 2x, so x is equal to d by 2. That means x equal to d by 2. That means the third charge is in the middle position. Okay, so you got the answer. The where the third charge d by 2, and what magnitude. The what magnitude, it will be in plus sign, it will be in plus sign. Okay, but if it is minus sign, is the there is the equilibrium state will be reached? Yes. If there is minus sign, then plus charge will attract towards this, and this plus charge will attract towards this. So there is also a possibility of being the equilibrium condition. Okay, so this is the answer, the x equal to d by 2. So this is a complete answer, but this is the first method. This is the first method of doing this, of solving this. Now comes the second method. Here comes the second method. Second method is the formula method. Okay, the formula method, second method states that x is equal to root q1 by root q1 plus q2 into L. Here the root q1 is root q1, and root q1 plus q2 are all 1. Okay, so 1 by 2 L, or D, it is D, 1 by 2 L or D. I am writing as D. L is the distance between them. I am writing as D. The formula is root q1 by root q1 plus q2. Root q1 only the magnitude will be placed here. Q1, the value of q is 1, and q2 is also 1. So 1 by 1 plus 1, 1 by 2 into D. So x is equal to D by 2. This is the formula method. But this formula comes from where? You have to know this. By this method, you will find the answer in a click. Okay, but you have to know the formula. Okay, so I am deriving the formula. So the formula is x equal to root q1 by root q1 plus q2 into L. Now I am deriving this. I am assuming that this is the q1 charge and this is the q2 charge, and this charge is separated by distance L. Okay, so I don't know the sign of the charges, so I am assuming that all the charges are positive in sign. So you already know that the positive sign, if the charges are in same sign, then the equilibrium position will remain in between the charges, not in middle, in between the charges. So I am assuming that I am placing the third charge here. So this length is x and this length is L minus x. Okay, so kq1 into q by x square is equal to k q2 into q by L minus x square. Clear? Now k, now here the electric field concept, here electric field options came, and the k q get cancel out. So q1 by x is equal to q2 by L minus x. That means x by L minus x by x is equal to q2 by q1. Okay, q1 by q2 is equal to q1 by x, q2 by x. Hence L by x minus 1 is equal to q2 by q1. Okay, now L by x is equal to 1 plus q2 by q1. That means x is equal to q1 plus q2 by q1. That means L by x, that means x is equal to q1 by q1 plus q2 into L. So where root L comes in this form. This is the actually root L, because I am rooting this. So root q1, root q2, root q2, root q1, root q1, root q2, root q1, root q1 plus root q2. This is the formula. Okay, we got the formula root q1 by root q1 plus q2 into L. Clear? Understood? If you don't understood, please comment below. I will make another separate video of this formula. For this is the formula for both the positive, both same charges. This is the formula for same charges, and there is another formula for opposite charges, that is root q2 by root q2 minus q1 into L. Okay, so here we assume that q1 is the q1 is the here we assume that q2 is the smaller bigger charge and q1 is the smaller charge. Okay, sorry, actually the formula is root q1 by root q2 minus q1. It is q1 by root q2 minus q1. If you don't understand this topic, then please comment below. I will make a separate video about this. So this is the method of second method, and there is the first method. You have to apply first method for board purpose, and you have to apply second method for your NEET and JEE purpose. So this is the second lesson of electrostatic and magnetic field, electricity 01, sorry, electrostatic 01. In later lesson we will learn about the electric field. So please stay tuned and watch the videos, and if we like our videos, my videos, so please support and share the video and like the video, and please subscribe our channel, so that we will I can give you the free education and better education. Okay, thank you.